maximize. There we go. Maximize that screen. And let's just do a warm-up problem, okay? We'll do a warm-up problem. Nothing too crazy. All right, and then we're going to get to the fun stuff, at least that's what I think it is. So we're going to subtract. We haven't done too many subtraction problems yet. Seven over 12 minus, no, let's do 7 over 16. 5 over 12. I think that's a nice problem. So do you want to do this together? Let's do this together. It's Friday. You know, it's Fun Float Friday. F to the third power. Fun Float Friday. So, I like to break things down until I get really, really good at this. So step 1, we're going to find that LCM. So I write 16, and I'm going to break that down. Let's see, that's going to be 4 2's being multiplied. Good, buddy, lay down. Lay down. Be a good boy. 12 is going to be 2 times 2 times 3. Now, if you bring all those numbers straight down, your LCM is going to be 2 times 2 times 2 times 2 times 3. So the LCM is going to be 48. Step 2. We're going to build equivalent fractions. Now, sometimes this is the part that we skip. Unfortunately, this is the most important part. So what I like to do is I will write the first fraction, 7 over 16. I'm going to write the multiplication by another fraction, and that has to equal a third fraction. However, that denominator is going to be 48. Okay? So just to refresh our memories, if we look at the prime factorization of 16, notice they all have the 4 2's in common. The only number that you're missing is what number, Stevie?
3.
The 3, very good. So I'm going to multiply 7 over 16 by 3 over 3. And that's going to give me an equivalent fraction of 21 over 48. For the second part, or the second fraction, 5 over 12. Notice with the 5 over 12, if you're comparing the prime factorization of 12 with the LCM, notice the first set of 2's, or the first set of 2 2's, and the 3 are all in common. What's the only thing that is not highlighted, Crystal?
The 2.
2 of them, right? 2 times 2 in the middle.
Mhm.
So we're going to multiply this second fraction by 4 over 4, because 2 times 2 is 4. And that's going to give me 20 over 48. All right. Here's our last step. It's just we're going to subtract and simplify. So 21 over 48 minus 20 over 48 equals 1 over 48. And 1 is in its simplest form already, so I don't have to simplify anything. I cannot stress this enough. Every single problem is done the same exact way. If you do it this way, it's very visual. You can see where all the numbers come from. Okay? And sometimes you will have to simplify at the end, sometimes you don't. That you gotta just try it. Okay? So let me give you one to do. This is all on your own. Try that. Negative 11 over 30 plus 27 over 40. All right, did anybody get an answer yet?
I got 37 over 120.
37 over 120, okay. All right, I don't know if that's correct. I didn't do it. So just give me 1 sec. I'm going to kind of set up my steps here. How's my handwriting today?
Actually looks good today.
What do you mean actually looks good today?
It's more legible today.
Here's yesterday's class. Look at that.
Yeah, kind of looks the same. I guess yesterday was better, or Wednesday.
Every day. My handwriting is on point. It looks legible today. Oh, geez. All right, here we go. Step 1. Let's break this down. Let's find our LCM. So 30. Let me see. 30 is what? 6 times 5. So it's going to be 2 times 3 times 5. 40 is what's that? 8 times 5. And 8 is 3 2s. So it's going to be 2 times 2 times 2 times 5. So give me a second.
I got a different answer, but I don't know how.
Okay, well, we're going to find out. We're going to find out. So before we even move on, are my breakdowns good? Let's see. 2 times 3 is 6 times 5 is 30. Check. 40, that's 8 times 5, and that's 40. So I think my prime factorizations are good. So my LCM, I'm just gonna drop everything straight down. A 2, a 2, a 2, a 3, and a 5. So my LCM is going to be 8 times 15, 120. All right. Now, build equivalent fractions. 11 over 30. I'm not going to worry about the negative in front of the 11. I'm not sweating that. Galileo, no. I can't hold you right now. There you go. So 11 over 30. And I know I'm going to multiply by a fraction, so I can build this equivalent fraction that has a denominator of 120. And next, when I look at 30, I will show you what I'm looking at. They match, and they match. The only ones that don't match are the 2 little 2's in the LCM. So I'm going to multiply this by 4. And that's going to give me 44 over 120. Am I right so far? Okay. Now we need to do 27 over 40. All right. So here, they match, and they match. So the only number I need is a 3. So I'm going to multiply by 3 over 3.
That's where I messed up.
Okay, good. So 27 over 3 is 81. So now I'm going to rewrite, subtract, and simplify. So negative 44 over 120 plus 81 over 120 equals, and for this, I'm going to just write one big numerator and one denominator. So the hard part here is I need to subtract, or I need to combine negative 44 plus 81. So signs of the numbers are different, which means I subtract the smaller number from the larger number and then keep the sign of the larger number. So in this case, it's going to be 37 over 120. Now 37 is prime, so I don't have to worry about simplifying anything. All right, how are we doing so far, everybody? Are there any questions or anything? Okay. All right, so we're going to go over one more problem that's like this, and then we're going to get into more heavier problems, okay? So here's the next one, and it's actually not difficult at all. It's going to look difficult, but once you see it, you're going to go, oh, no, that was actually painless, okay? So we have 3 over 5 plus x over 8. No, we are not solving here. There's no equal sign. You were just simplifying, okay? Now, have we seen an example where there's a variable yet in this class when we're dealing with fractions? We have?
Yeah, when we were doing division, we did 5 over 3 divided by q over 3.
Okay, and what about when we were adding and subtracting with like denominators?
No.
Are you sure? I mean, I can go back and look.
Oh yeah, we did. We did negative
didn't we?
6 over m plus 9 over m. And then we also did y over 7 plus 2 over 7. Oh, yeah.
Yep, the 2 that I have on the board. Now the reason why I'm going over this, right, is if you look here and here, denominators are the same, so we just wrote one big numerator and wrote the denominator underneath. Is that correct, everybody? So if we go back to our problem, why would this change? Does your technique change? Do steps 1, 2, and 3 change? Not at all. See, here's a problem you've never seen before, yet you already know how to solve it. All you got to do, step 1 is find that LCM. Could you put the gate up so he doesn't?
Is he in here?
I don't know.
He's not in here.
Oh, could you get him in here then? Thank you. So here's step 1. Let's find that common denominator. Or, I'm sorry, the LCM. I like saying the LCM better.
Well, he had zucchini bread for breakfast.
Oh, he had zucchini bread for breakfast.
Yes, he did.
Oh, excellent. Because my dog got the zucchini bread that I left out. So my LCM is going to be 2 times 2 times 2 times 5. Or 40. Step 2. We're going to build those equivalent fractions. So the first one is 3 over 5. So the number I'm going to multiply by is going to be 8, or I'm sorry, 8 over 8. So 3 times 8 is what? Is that 21 or 24? I can't remember.
24.
Thank you so much. Now let's go ahead. Now this second one is x over 8, and we know we have to multiply by something. So that something is going to be a 5. So it's going to be 5 over 5. However, x times 5 is just 5x. It's 5 times x. If you knew what x was, you would multiply those two numbers together. Unfortunately, you don't. So you just write it as 5 times x. Step 3. We're going to rewrite. And simplify. So I have 24 over 40 plus 5x over 40 equals one big numerator over your denominator. And since you cannot combine 24 plus 5 times x, you don't even have to simplify anything. You literally just leave it like that. All right? So personally, I think this problem is easier than the previous ones because it was less work. You didn't have to worry about negative 44 plus 81. You had to remember your rules for integers.
Hey, Miss, really quickly, I understand this and I think it's actually easy, but I always slow down and get confused. Not confused, but I'd like struggle for a second with like finding what you multiply them by.
So you're saying this step right here.
Yeah, I don't know.
All right,
Why?
I think it's a valid question. You ready? So
Yeah.
In this previous problem here, let me erase some stuff real quick.
Because I just immediately want to go over and see like, okay, what times 30 would equal 120? Because I know the LCM is 120 and I want to do it that way to find the, you know what I mean?
No, I totally get it. So when we're talking about this middle step, Kim, all right, and your thought process is correct. You're sitting there thinking, what number times 30 equals 120? Am I right? So
yeah.
What we're doing, what I do over here on the left-hand side, and the reason why I'm highlighting this is right here is the prime factorization for 30. So in your LCM, you already have the number 30 in there. Okay, does that make sense? The question becomes, come on. There we go. Out of your LCM, what's left over? Because if you think about it, 2 times 3 times 5, which is highlighted in blue, is 30. Come on, bro. So that number right there is 30. Would you agree? What's this number right here?
2 times 2, so 4.
And guess what 30 times 4 is?
Yeah, 120.
That's how we're getting it.
And yeah, I see how you're getting it. And then like, so the next problem, you see what's left for 40. Okay, now I see.
Yep.
I see. You
Yep.
go
So,
up.
so like, for example, and I know it's really simple. We'll go over it real quick.
It is so simple. I don't know why I'm like,
Would you like me to tell you?
sure. Because I learned a different way and
No. You're just too smart. You're moving too fast.
I am moving too fast. I am.
The hardest part about learning math or learning just anything in general is just to slow yourself down.
Yeah.
But
Yeah.
your life, you got kids, you got a husband, right? You're probably full steam almost every single day. So how can I expect you just to sit down one day and just go, okay, I'm going to slow life down. I'm going to slow my. That's like the impossible task to ask. So all I can do is just remind you, hey, slow it down a little bit. All right. So and I think this is excellent. So I'm going to go over it one more time for those in the crowd that didn't ask the question. When we look at this number 5, it's already right there. Okay. So the question, what times 5 equals 40? Well, 2 times 2 times 2 is 8. So that's why I'm writing 8 over 8. For the second equivalent fraction, you already have the 8 in your denominator. So these 3 numbers right here, 2 times 2 times 2, gives you 8. Guess what 8 times 5 is? 40. So if you just write out step 1 the way that we're writing it out, you don't have to guess. All you have to do is kind of just like say to yourself, all right, well, here's 8, so I'm going to scratch it out. That number right there is going to tell me what goes right there. Does that make sense, everyone?
Definitely.
Okay. All right. So this is the part of the lecture where I sit there and go, okay, guess what? All of our techniques are done. We're not learning any new techniques now, which is I think a really good thing. You know how to multiply fractions. You know how to divide fractions. You should know how to simplify fractions. You also know how to add and subtract fractions regardless of the denominator. If they're the same, you should know how to do that. And if they're different, we got 3 steps here to help us with it. Now comes the time where I just go, okay, let's just start doing random problems now. This is kind of like there's a big hat, you're closing your eyes, you're reaching down in, you're pulling out a problem, and that problem happens to look like this. Now this is something here we've never ever seen before. However, and I'm going to tell you, everything that you need to learn, or everything that you've learned so far, you could do in this problem. You already know how to do this problem. So, somebody talk to me. What do we have here? What do you see? What bothers you?
That the half is in, first of all, that it's a half and it's in parentheses.
Okay, is that it? About that 1/2 in parentheses? Or is there one more thing, Kim?
Maybe the exponents, but yeah.
What?
But I'm more confused about the half.
Okay, so the half is in parentheses. Guess what? It's just a fraction. That's it. What does that exponent tell us to do?
Multiply.
Multiply it. How do we multiply it by 2, or do we say 1/2 times 1/2? Because that's important.
1/2 by 1.
All right, so here's what I'm going to do. Off to the right-hand side.
I feel like it's easier when it's written, when division's written like across instead of on top of each other like that.
It's really good that you, no, it's really good that you recognize that too.
Yeah.
So this is really, everyone, before I even get started, this is really the quantity 1/2 to the second power divided by 4 plus 3 to the second power. Now, because we have that big fraction Not the little 1/2. I'm talking like the big thing overall. I'm just going to simplify the top first. So I'm going to do exactly what I think it was Stevie and LaKendra. They kind of said it at the same time, which was 1/2 times 1/2. Now, we know how to multiply fractions. You simplify if you can first, and then you multiply the leftovers. So if I look here, 1/2 is simplified. So there's nothing I can simplify, so I'm just going to multiply from left to right. 1 times 1 is 1. 2 times 2 is 4. So in the numerator, I have 1/4. And that's it. Now let's worry about that big denominator, the 4 plus 3 to the second power. What do you got to do first?
Exponent.
Okay, so 3 to the second power means
3 times 3.
which is 9. So we have 4 plus 9. So far, so good, everyone? Now, is that big denominator, the 4 plus 9, is it completely simplified yet?
No.
No, what can you do?
Add those two together.
So what's 4 plus 9?
13.
13. And I think that was Anaya that gave us the, no, they're not done. So good job. Excellent. So now you have 1/4 divided by 13. Am I correct? So it kind of looks like in the big numerator you have a fraction, but underneath you have a whole number. Is that right?
Yeah, but you can put 13 over 1.
Perfect. So I'm going to write that in red so everybody can see that. So 1/4 divided by 13 over 1. Well, don't we know how to divide fractions? How do you divide fractions?
You're gonna multiply it by the reciprocal.
Okay, but there's one step. You're moving way too fast, Stevie.
Oh, sorry.
You forgot the very first step.
Write them side by side.
Nope. Remember, this is the we slow down part. Rewrite the first fraction. I know you heard me say that before. Division changes the multiplication. And then we multiply by the reciprocal, or we just flip. 13 over 1 now becomes 1/13. So now we're just multiplying two fractions. Simplify first if you can. In this situation, we can't. 1 times 1 is 1. 4 times 13 is 52. Are there any questions with this problem? Have we done everything prior to this problem, like in this problem? Like, did we learn exponents? Did we learn how to multiply fractions? Did we learn how to divide fractions? I mean, everything's there. All right? It's just now, instead of doing like each little individual thing, we're just bringing it all together in one problem. The hardest part about this is going to be slowing yourself down. Talk out loud if you have to. You know, I'm constantly talking to myself out loud. Not in public. When I'm at home, I do it all the time. All right? I'm going to give you one. This problem is going to be similar to this one. It's not going to be the same, but it's going to be similar, and I just want you to do it.
Are you going to put homework on WebAssign?
Yes.
Okay. Just
Yeah,
making
because
sure.
now we have enough that I can do it. All right? Otherwise, you would have had like one homework assignment with like 4 problems on it. Now you got me all flustered, and Stevie's going to make fun of my handwriting. So I need to make sure it's perfect. Yeah, we're still in section 4.5, by the way. Like, we've been doing 4.5 since Monday. When was the last time it took us 3 days to do one section? And that's a good thing, because I wanted us to take our time. I would love for this to happen. if you don't take my class next semester, however, you're in another math course, and it comes fraction time, and you were just nailing every fraction, and it would be nice if the professor is like, who did you have for 80? You're getting all these fractions correct. And you're like, I had float. That would be awesome. Does anybody have an answer yet, or are you still working? It's okay if you're still working.
I got 1/256. I don't know if that's right though.
1 over 256?
Yeah, probably is so wrong.
Yeah, I think that's a little bit big.
I got
Anybody else?
272.
What
I
did you
got 272 over 1.
Yeah, 272 over 1.
Okay, let's do this problem then. All right. Boy, that 200, that's an awful large number, but maybe that's it. Maybe that's what it is. Maybe that's what it is. Isn't that like a song back in like the 80s or 90s? That's just the way it is. Do-do-do, do-do-do, do-do-do. Every time I hear that song come on, I'd punch somebody. I wouldn't do that. It's just not a good song. I don't think it's a good song. But anyways. All right, so we have a big fraction here. We have 1 plus 4 to the second in the numerator. And then in the denominator, we have 1/4 to the second power. So what I'm going to do is I'm going to worry about the numerator first. I'm going to get that all squared away. And then I'll worry about the denominator. And then I'll divide at the very last step, just like we did. So scratch work on the right-hand side. 1 plus 4 to the second. Well, that's going to be 1 plus 16, which is 17. Does everybody agree with that? Okay. Now, downstairs, 1/4 to the second power means 1/4 times 1/4. There's nothing I can simplify, so I get 1 over 16. Everybody agree with that? All right. So now from here, the next step. Well, I noticed that I have 17, which is a whole number, divided by 1 over 16. But what I can do is I can rewrite any whole number as a fraction just by putting it over 1. So now this looks a lot more doable for me. I have a fraction divided by a fraction. So I rewrite the first. Division changes the multiplication. And I'm going to flip the second. 1 over 16 becomes 16 over 1. And now that large number that everyone was getting actually looks really good. 17 times 16 is 272. And 1 times 1 is 1. So if you wrote 272 over 1, that's fine. Or just 272. How are we looking so far? Pretty good? I'm telling you, fractions are easy. There's a lot of it's tedious, but this is where you build that really strong foundation.
You know, it makes sense now. So I took like the placement test for math and I hated fractions before I had your class. Because I never understood fractions over fractions. I just thought it was just one big fraction and I never knew how to start it.
Well, I guess in a way it is just one big fraction, but if you gotta just be able to see that you're breaking it down a little bit. That's it.
Yeah, now that I know the steps of how to even start it, it's a lot easier to look at.
Good. And that's what it's all about. Oh, that's 1/3. You're almost becoming what I like to call a math surgeon. I know it sounds weird, but surgeons, they go into a specific spot on the body and they try to repair something. Maybe it's your knee or you know what I mean? Maybe you tore a tendon in your elbow. So it's a very specific spot where they fix. That's all you're doing here. So in this example, we have 1/3 plus 1/2 all divided by 3/4 minus 1/3. So we're going to be surgeons. We're going to look only at the top. So we're only going to look at the top. And we're going to say, okay, let's just add 1/3 plus 1/2. Okay? Now here, we need to do our steps. All right? So let's go ahead. Let's do them. And it's tedious. And maybe that's another reason why people hate fractions. It does take a lot longer to do than other problems. But I'd rather be doing math inside where it's warm and comfortable on October 1st than I can hear the trucks at the bottom of the road redoing our street right now. I don't know about you, but I think a pen is easier than like a shovel. All right? That's just me though. And there's nothing wrong with that work. My dad does that. It's just, for me, I don't want to do that. So here we go. 1/3 plus 1/2. So my LCM is going to be 2 times 3, which is 6. How are we looking so far, everyone? Good. Next step, let's build equivalent fractions. And now you can see I'm kind of speeding up here a little bit. So what am I going to multiply 1/3 by? Well, that's going to be 2 over 2. And that's going to give me 2/6. What am I going to multiply 1/2 by? Well, that's going to be 3 over 3. And that's going to be 3/6. So underneath, we have 2/6 plus 3/6, which equals 5/6. So that is what goes in my big numerator. How are we looking so far, everyone? Okay? So I'm going to wait. I'm going to give you, maybe 30 seconds here so you can write down the scratch work because I'm actually going to erase that scratch work. Remember, I'm recording this. So if you want to watch the lecture video back, you can always pause it. Speaking of that, and you don't have to, it's there for your pleasure. Any of us watch the videos again? Sometimes Anaya? Okay, good. Stevie or Stephanie, you did? Okay, good. Like I said, you don't have to watch them. I just why not just upload them? Takes me minimal work. It's dragging and clicking. All right, so I'm going to erase. And we're going to do the same thing. For the big denominator. So we have 3 over 4 minus 1/3. Okay, so LCM. 4 is going to be 2 times 2. 3 is prime, so it's just going to be a 3. So my LCM is going to be 2 times 2 times 3, which is 12. Equivalent fraction time. 3/4 times something. It's going to give me a fraction with a 12 as the denominator. And then 1/3 times something is going to give me a fraction with a 12 in a denominator. So the first one, 3/4 times, well, it looks like it has to be a 3. So I write 3/3. 3 times 3 is 9. For the second fraction, 1/3, I have to multiply that by 4/4. Does everybody see where I got the 3/3 and the 4/4 from? There are no questions with that. Okay. So let's rewrite and combine. Now, just be careful. It's 9/12 minus 4/12. And that's going to be 5/12. All right. So now I have a fraction divided by a fraction. 5/6 divided by 5/12. So I rewrite the first. I multiply by the reciprocal of the second. Now here, I can definitely simplify some stuff. So let's look at that very first fraction. The 5/6. 5 is prime. 6 is 2 times 3. For the second fraction, that 12, I can break that down. 2 times 2 times 3. And that 5 is prime. Now, maybe from here you can see it. What numbers can I simplify?
2, 3, and 5.
All right, so let's take this one step at a time. So the 5s I can reduce. One of the 2s I can reduce. And one of the 3s I can reduce. Now, since everything is scratched out in the denominator, what does that denominator become?
1.
Very good. What's left over in the numerator?
2.
So the answer is 2/1 or just 2. Does that make sense, everyone? Now, there is something that I want us to kind of look at before we move on. All right, there is something I want us to look at. So, what I'd like you to do right now is just put the pencils down, just look at the screen, because I'm going to highlight some stuff. All right. I don't know if you can read those things, but I highlighted them. I want you to notice something. I want you to compare the first highlighted blue section to the second highlighted blue section. What do you notice that's the same?
They all have 1s in either the numerator or denominator.
Okay, but if you compare that, Stevie, with the third, there's no 1s there. So that's okay. Try again. How about this? Stop focusing on the numbers and look at the form. What form is it in?
A fraction?
Keep going.
Fraction over a fraction.
Okay, what about the second one?
Same.
What about the third?
Same, but the denominator, yeah, same.
Same. 3 problems, all different, but they all converged to a fraction divided by a fraction. So guess what you always want to try to do? Get your answers or simplify down into a fraction divided by a fraction. Does that make sense, everyone? 3 different problems, but they all converge at the same point. That's awesome. So make sure when you're going through this, And I know we are so fixed on numbers. Sometimes you need to take a step back, a 30,000 foot view, and say, what's the form? What am I given? Does that make sense, everyone? All right. So there is just one thing I want to do. One last thing today. Is just evaluate. I know we've seen this before. When we see the words evaluate, or what words, I say it like it's plural. When we see the word evaluate, what are we thinking?
Solve.
No, there's no equal sign there.
Oh, I knew you were going to say that.
Simplify.
Simplify, very good. So directly underneath, I'll rewrite the problem. And then where I see the variable, I'm going to put parentheses. Now I make my substitution. In this case, they're saying x equals negative 5 over 4. So I'm going to substitute in negative 5 over 4. So, from a 30,000 foot view, what is the form here? I don't care about the numbers. What are we doing?
Multiplication? No.
Nope, be careful.
Adding a fraction over a fraction.
We're adding two fractions. Very good. Now, as soon as you establish we were adding fractions, there needs to be two questions in your head. And what are those two questions?
Common denominator.
Are the denominators the same? Or are they different? In this case, they're what?
The same.
So do I have to worry about finding a common denominator? So I can rewrite this with a 4 underneath. And then a negative 5 plus 3 in a numerator. And what is negative 5 plus 3?
Negative 2.
Negative 2. Now, anytime I simplify, I always need to make sure that that end result is completely reduced. Is that correct? Negative 2 over 4. Is that simplified? All right. What's it simplify down into?
Negative 1/2.
Negative 1/2. How are we looking so far, everybody? Was that difficult? Anaya, I have a question for you. Who is that?
That was my daughter. I'm sorry.
She's
She doesn't feel well.
She's the cutest little girl I think I've ever seen.
Thank you.
Yeah, I love her hair. That's the first thing I look for, hair. Especially when I met my wife. I was like, does she have good hair? Because I don't have any. So Molly and I ever have kids, hopefully they get her hair and not mine. I started going bald at like 20. So I just said, game over. I'm just shaving it. And then my best friend goes, boy, you look really good with a shaved head. And I was like, what? Was I like chopped liver before? He's like, yeah, you weren't that good. All right, let's do this. It's Friday.